Moisture content test. The objective of this test is determining the moisture content of fine aggregate and coarse aggregate. We can conduct it for soil also, but in this case we will conduct the fine aggregate, that means the sand, and the coarse aggregate, the gravel one. We will conduct the determining moisture content of a given sample. So how much moisture is contained in sand and in gravel. In concrete, water cement ratio is specified on assumption of aggregate are inert. That means the aggregate or the sand, it is not absorb any water or give water to the mix. So we can call or we will assume that aggregate are inert. So the water cement ratio must be calculated according to that one. So wet aggregate gives water to the mix. That means it will less the strength of the concrete, and the drier aggregate take water from the mix that affect the strength of and the workability of the concrete. So in order to correct these things, we will determine the moisture content of an aggregate, that means the fine and the coarse one. To determine moisture content of sand and gravel or any material, construction material, we use these apparatuses. The first one and the main thing is oven one. It is drying oven. It is measure can. It is content of sand sample. It is can. It is content of gravel. So coarse aggregate, fine aggregate. This one is the balance or digital balance to weight or to check the balance of the weight of the materials. In this case, we'll test the moisture content of sand and gravel. Okay, the test procedure to conduct moisture content of a material is the first step will be preparing all apparatuses and materials. It is prepare the material for sand and it is for gravel. So the first thing is determining the moist sample and the can. So we will put it in digital balance and we will measure this one. So it is called mass of can and mass of moist gravel. So it's called 0.4 kilograms and we'll put it in oven later. So we will add the sand one. So we will put it this one and it is 0.22 kilograms. This one is the sand, that one is the gravel one ማለት ነው። So ማለት ነው አልኩኝ እንዴ? ልቀጥል? Okay. So we will, after measuring the can and the sample, we will add it this one into the oven. So we will put this thing in oven for 105 degrees Celsius for 24 hours. So after 24 hours, we will continue our experiment. In moisture content determination, after 24 hours, we will come back and we make it off first and we make it cool. So we will open this thing. It is very hot, so we must wear a glove. So by using glove, we make it out, the aggregate one. So it is dried. After outing out the material, we make it a measure. So this one is a dry sample, it is oven dried. So oven dry plus the can, it is 0.195 kilograms. It is oven dry sample. So but we will remove the sample and we measure the can. So mass of can is 0.075 kilograms. When you come to the aggregate one, we measure, it is oven dry sample, oven dry 0.390 kilograms. It is oven dry with can, and the can value or the weight of the can is 0.075 kilograms. So we will calculate the moisture content of test by calculation method. We will forward to that one. The calculation determine water content of or moisture content of a given sample is equal to A minus B over A times 100. where W is moisture content in percentage. We can call it water content of a given sample. A is weight of original sample in grams. It can be in kilograms. B is weight of oven dry sample in gram. You can call it in kilogram. So according to our lab result on gravel sample, A or the weight of original sample is, that means the moist gravel, 0.4 kilograms. But we will neglect the can, that means the containing is a container. So the container weight is 0.075 kilogram. So by subtracting 0.4 kilogram minus 0.075 kilogram, it is 0.325 kilogram. B. Weight of oven dry sample 0.39 kilograms, but we will neglect the 0.075 kilograms, that means the can or the container 0.315 kilograms. Note 0.075 kilogram is mass of can, it must be subtracted. So by inserting the lab result, we can get the moisture content or the water content of a gravel is 3.17%. When it comes to the sand, it is the same procedure. That means the A is 0.145 and the B is 0.12. The mass of can is 0.075. It is subtracted. So by using this formula, A minus B over B times 100, we can get 20.83. That means the sand is contain more water than the gravel. Thank you for watching.